Hello and welcome to lecture number 7 in web engineering. And today we're going to talk about web servers. So we're going to move away from the front-end side of things in web engineering, namely what's happening in the browser, what is JavaScript and HTML and CSS, and now we're moving into the realm of the backend, which we're now going to start with web servers. So today we're going to have a relatively short session, and we're going to give a quick overview of what web servers are. I'm not going to go into too much depth. I just want you to know if you hear the term web servers, what that actually means. So I hope everyone can hear me okay. Can you give me a quick hands up in the attendees, just so I know? Okay, so that looks good. So last time I had an issue with the questions you were asking, and the issue was that there are two windows here. The one is the chat, and the other one is the questions. Now I know that both of those exist. So if you do ask questions, I will see them now, and I will look regularly whether you have questions. So before we start the actual lecture, I want to talk about one more thing. So in the announcement that I sent out today, there was the mention of this bonus round, bonus points that you can get, and this is part of a research study that we're doing in our group. So as part of a research group, we do teaching. So we teach web engineering in this case, but we also do research, and in that case, the research is about understanding how people work with JavaScript. And one part of that is how they work with JavaScript in any kind of console where they have interactive experience and exploration with the browser or with Node. So if you're interested in that, let us know. So here in the PDF that we have on Toolwell, we have this this form that we can register. It's just your name and an email so that we know who's interested in that. And we also gave an example on how we want to collect that data. So if you want to participate in the study, the method that we're using is called diary study. So what you do is every time you go into the console, be it in, let's say, that's an example I'm going to show later. Let's say I'm going to go into tools and developer tools. And here I just do any sort of exploration and say, well, document.getElement by tag, elements by tag. Let me say span, right? That's not even a function. See, so this is already something that I'm thinking in my mind. Okay, it has to be elements by tag, and then I try it out, and then it's actually not get elements by tag, but then I interactively get that feedback. So that's what we're looking for, right? I see, okay, I failed at something. Now I have to look at the API and see how to do it better. So I say document.get, and then I have tag elements by tag name. All right, so now I know elements by tag name, span. Okay, and then I have to have this collection, and I actually want to here, and then within those spans, I may want to have a loop over those, and so on and so forth. So this would be an exploration section, and this is something that you can then document as part of a document, a Google Doc, for instance, or any other sort of live document. And the way this looks like is, so we have an example here. You say you have a session where you tried out something or you have some exploration. You tell us how long it actually took approximately. You tell us what sort of REPL you used. REPL stands for read, eval, print loop. So what we saw before, you read some output, you evaluate it, it's printed, and that happens in a loop. And then you annotate this information here. So you say, well, here I made a mistake. So in the case of the browser, I would say, hey, I made a mistake. I didn't know the exact name of the API endpoint. And so I go back and annotate that and say, what was my thinking? What was my rationale of doing all this? Right. And the other way of doing this is in the console. So we have a node console where we say, yeah, here I have an example. So you can say, let's close this up. You can just say node, for instance, and that brings you into the Node.js JavaScript console. And this is more important for, I would say, the next couple of exercises where you're going to work with Node a little bit more. And here is an example that you can look here. I had this variable x, let's call it y in this case. Oops. And I kind of want to figure out how does splice actually work. Splice is such a weird method. What does it return? Does it change the actual array? Right. So then I say, well, and let's say what happens if I go over the length, right? So if I say, 20 and splice 2 elements. Well, it returns nothing to me. It's fine, and it keeps the array intact. But if it was splice on let's say 2 and 1, okay, so it splices out the 6. And if I look at y, it changes the underlying array. All right, so this would also be an exploration session. So those are small sessions, and larger sessions would be something like you're exploring an API in more full terms. You try to figure out what is the response, how you deal with the data of the response, and so on and so forth. So this would be a very short session, and the longer sessions would be quite a bit longer, actually, where we go into more depth and explore a certain topic. So if that's something that is interesting to you, let us know in the forum. And what you can gain by this is, I would say, experience and how this sort of research works. And the other one is you can get bonus points. So if you do this well and you document this well, and then we have a conversation about this in the end, you can get up to 10 bonus points. And what that means, and you will add those to your theoretical points. Meaning that here's an example, if you get 75 points on both tests, so test 1 and test 2, together you have 75 out of 100 points. If you get all the points for this bonus round, you will have 85 out of 100 points. So that's quite a bit of a bonus, and that should reflect your effort that you'd have while recording this diary. Okay. Any questions on that? I see one hand up by Alexander, but I'm not sure if that's still from last time. No. Okay. All right. So with that, let's close this up and actually start the session. Oh, and before, I forgot to send it out in my email, but then Michael Schröder sent out the announcement for tutoring hours. So today and on Thursday, we have tutoring hours for assignment 2. So if you want to participate, we have 2 today and 2 on Thursday. So, and with that, let's actually start the lecture. I have to switch to my other screen. There you go. All right, so today we're going to do a very broad overview on web servers. And when I say web servers, I mean it as a bit of an ambiguous term, namely the hardware and the server software that are both called web servers. I want you to understand how web servers are part of the internet architecture. We're going to talk about serving both static resources from the file system and then dynamic resources through a programming language. In the end, I want you to understand the difference between web servers' hardware and its software. I want you to place web servers, especially the hardware part, as part of a broader map in the internet architecture. I want you to be able to describe the difference of serving static and dynamic resources with respect to web servers. And eventually, we're going to look at a very small example, actually, on how to write a very basic web server in JavaScript and Node.js. Right? And please, if you do have questions, just interrupt me. I see both your hands pretty well right now because I have, oh, can't see the mouse. It's great. So I might have to jump out of this mode sometimes. But if you ask me a question, I will see the question right away. Great. So let's have a quick recap. If you remember the first lecture, we talked about HTTP. We also talked about how a client, if you type in, let's say, google.at into your browser, but any sort of request that you do with HTTP, from a browser, from any other device or server, will first trigger DNS. So it will take this domain name and translate it to an IP address. And then with this IP address, it will send requests to a server, okay? And the server will then provide you with the resources that you need based on the URL that you gave them. In between, we have certain intermediary proxies, and we have requests and responses. I think by now, we all know how requests and responses work, so I'm not going to go into that too much. But the focus of this lecture is this part, the server part. And I already mentioned this before a little bit. Web server is a bit of an ambiguous term because it means the hardware, the physical often system, and the simplest way of thinking about a web server or a server in general is that it's some computer that is connected to the internet or any network for that matter, if you want to connect to the server on a local network, that you can talk to with HTTP. And the HTTP part is the software part of all this. So on this physical or virtual server, I'm going to go into this in a bit, there's a program running, right, that on that computer or server, whatever you want to call it, accepts HTTP connections over a socket meaning the port that you're open, and can also answer with HTTP responses. That's the basic high-level thing. That's all a web server is. Certainly, there are more complicated things that are involved in modern and contemporary web servers, but that's just a plus. If your web server can do this, it's already a web server. So let's talk a bit about the hardware. So in the hardware part, there are certain properties of I would say contemporary servers. While obviously you can have your own computer in at home or in your office, and you can connect it to the internet and configure the firewall in a way that accepts connections, that's already a server, no doubt. But most of the servers that are online are usually part of large data centers. So if you look at the picture to the right, what you see there is called a rack, and within a rack you have multiple servers that are connected through those wires, network cables, and within those servers, you have often something called virtual servers. So probably many of you have already heard about virtual servers, but I'm gonna talk about it anyway for a little bit. Just I think it's important because if you haven't heard of it, it might be interesting to know. And another thing is that oftentimes an application is part of multiple data centers, because latency, meaning how fast or how performant your application is often geographically dependent. Okay, so oftentimes your application doesn't live in just one data center, it lives in multiple data centers. Okay. And for testing purposes, and you've already seen this in assignment 2 actually, your own computer for yourself can be a web server. So we had this in the test folder. You were able to say npm run server, or you can do it with Python, for instance, and you can have a local server running, and you can access it with localhost. So just a quick word about DNS. So when I said a couple slides ago and in lecture 1 that DNS, you can think of DNS as a function from a domain name to one IP address. I lied a little bit, because DNS is maybe a bit more complicated, because oftentimes, and again, pretty vague and I would say abstracted away from the reality of all this, but for you to understand, DNS most of the time is a function from host name and some notion of location to an IP address. And you can see an example on the right here. So, and oftentimes, the location that I have in quotes here is just your IP address. And based on your IP address, but then there are also sometimes other factors that go into this. But let's say just your IP address for now. You go to your local DNS, which is usually provided by your ISP, your internet service provider. And they will then, if they have the entry of the IP in their local registry, if they have it cached, great, they give it back to you, and you can go directly to the data center that you need. If not, it will go to the let's say, global DNS server, and the global DNS server will, based on the IP address of the local DNS, return to you an IP address of what they think will provide a better performance for you. Okay, so that's what I want to kind of convey here, is that oftentimes a web server is definitely one thing, but in reality, what happens is that you have geographically distributed web servers, and DNS is a way of dealing with that. One way of dealing with that. And then I want to point out virtual servers and containers. So again, I think most of you have heard about virtual machines before. So what both virtual machines and containers enable for you is the ability to run multiple servers actually, or multiple isolated instances of operating systems on one machine, right? And what that does is it increases utilization to your server, because oftentimes those servers that you saw before in data centers and racks are very powerful. And a lot of times, one person or one organization doesn't need the full power of that machine. So what people do is they don't give you the full machine, right? If you have a bare metal machine and you need the full one, then you're doing something very special. Nowadays, what you usually get, if you get any of these servers, you get a virtual machine. And what it does is it enables you to have a virtual instance of an operating system, right? And it does so by having a virtualization layer. And that layer is called the hypervisor. And what the hypervisor does is it divides physical resources on that server and allocates them to the virtual instance. It tells virtual machine number one, well, you get 4 gigabytes of RAM and 7 gigabytes of storage, for instance, right? Just an example. And it provides that isolation for you. And then what it also does is the hypervisor, and it's a bit of more of a complicated process, but think of it as it translates the kernel operations from the guest operating system, the one of the virtual machine, to the host operating system, the one that is hosting all those different virtual machines, right? So in the case of virtual machines, and there are many different companies that offer that, what you can have is you can have a host operating system that is, let's say, Linux, and then the guest can be Windows, can be Mac, can be anything you want, right? Because the kernel doesn't have to be the same. And that's the main difference between virtual machines and containers. So containers are not really virtualized. They feel the same way as a virtual machine does. However, they don't have the same level of isolation. What containers do is they provide a lightweight process isolation. They kind of look like, because they have their own file system, they have their own isolated processes. So if you are within a container, it sort of feels like you are in your own isolated machine. However, the way that the separation works is through something called C groups. And what they do is that they isolate the processes. And it doesn't have the same security boundaries that virtual machines have. And also, the kernel of the guest operating system has to be the same as the kernel of the host, right? But you might say that, you've probably heard of Docker before. Docker is, I would say, currently a very popular offering for containers. You might say, well, my Docker also works on Mac and on Windows, but my guest operating system might be in Ubuntu or any other Linux. So the thing is that there's a very thin layer that does a little bit of the translation that the hypervisor does, but not on the same level, right? It cannot give you the same separation as a hypervisor will do in the case of virtual machines. And usually you still share a kernel, and the way they do it within Windows and the Mac is that they actually start a virtual machine with Linux and run Docker on top of that. Although there's so many recent developments that I can't really keep up too much. I'm sure that it has changed a little bit, that they have a more seamless kind of translation layer, but all in all, you have to share a kernel, and then also makes containers a bit faster. Okay, so there's a question by Anna, is that true? Okay, Anna? Okay, no question. Or maybe later. All right, if you have a question, maybe just ask it in the question section, and I will see it. All right. Okay, but overall, what both virtual machines and containers give you is the ability to have multiple organized servers, logical servers at least, on one physical machine. And that's what is happening all the time nowadays. Okay. Oh yeah, there you go. So, and then I want to briefly mention the cloud, because I feel that the cloud is very overhyped in many ways, and misunderstood in also many ways. And actually, if you understand virtual machines, you already sort of understand the cloud, not all the nuances, but I want to quickly just let you know how you can see the cloud or parts of the cloud. So if you look at the graphic to the right, if you look at the left part, you start with something called IaaS. You go to PaaS and SaaS, infrastructure as a service, platform as a service, and software as a service. And with every way you go to the right, you increase the abstraction level. And if you go from right to left, there you get less restricted. So infrastructure as a service, what that actually is, if you want to summarize it, it's API-driven infrastructure at scale. And that can also be web servers. What that means is that you can get a virtual machine, right, on Amazon or what have you, by accessing an API and telling them, I want to have a machine with this configuration, and they will return one to you that you can use. And then, can be offered for users to access, right? So you can write a script that automates this process for you, okay? And that's what infrastructure as a service is. It allows you to provision and retrieve computational resources. In the case of infrastructure as a service, you get an actual virtual machine assigned to you that you can then use. And then there are countless examples out there. Just to name a few, I think the most famous one probably is the Amazon Web Service EC2, where you can get those resources. There's Google Compute Engine. DigitalOcean has an API for that too. And what that enables you to do is something called horizontal, but also vertical scaling. Horizontal scaling means that if you have a lot of load on your system and you have a load balancer before your system, and it sees, well, my system, let's say, goes over 80% CPU, it can start up new instances automatically for you, right? How that works exactly is, I would say, a topic for advanced web engineering or distributed systems or what have you, but this is essentially how it works. Then I think more interesting for us now, and maybe I'll show a demo of this later in the semester, is platform as a service. Because with infrastructure as a service, you do get very easy access to computational resources, but you still have to configure them yourself. You have to go, you have to write scripts to provision the server and do a lot of configuration for you. In platform as a service, you retrieve a managed application runtime for one particular domain. Let's say you want to deploy a JavaScript and Node.js backend. There are services that provide a platform for you to do that. That means that the underlying infrastructure, the actual server, is abstracted away from you, right? What you do is you provide higher level configuration that provides some directives. You tell them, I want to have some sort of performance. It's more declarative than it is imperative, right? I think that's a better way to put it. In infrastructure as a service, you have to sort of imperatively define the infrastructure that you want. You have a lot of configuration that is very low level. Whereas in platform as a service, all those low level things are abstracted away from you, and you just provide very high level configuration options of what you want to have. There's a question by Alex. 1 second. My mouse is just being weird here. Come on. There you go. Nope, it's still gone. Okay, I'm assuming the question may be, is the lecture going to be recorded? The lecture is going to be recorded and the slides will be online. I hope that answers it. I don't know why I can't just go over here. I can. The mouse is just not visible to me. That's great. Anyway, so I'm going to continue for a second and then move on to questions. So probably later in the semester, I will show a demo on how to, for instance, deploy assignment 3 as part of one of these platforms as a service offerings. I think Heroku has great usability, has great documentation, and it works in the way that you provide a different target for your Git repo. And then if you push to that target, to your remote, it will push to the Heroku resource Heroku will understand what kind of application it is. If it's standard application, sometimes you have to provide some directive, and then we'll deploy it automatically for you. And that's super convenient. There's nothing you need to do. And I think that's something that everybody should know on how it looks like. So I'll probably show an example of this maybe next week. But that's essentially what, the whole Mystic cloud is, basically. The last part of this graphic with the software as a service just means that someone is hosting the whole application for you, and you maybe can provide even higher level configuration to say, what part of the application you want to have. That's not something that we want for web engineering. In web engineering, we want to deploy our own software. Okay. There's actually a paper that I published with colleagues 5 years ago called The Making of Cloud Applications. If you're interested, it was published in 2015 at FSC, and it's online on archive, where we interviewed a bunch of people that deploy software to the cloud. And interestingly, it aged pretty well. So I would have thought that some of the concepts are now outdated, but honestly, I think the concepts that we figured out there stay the same. Okay, so now we hopefully understand what the hardware part or the physical part of web servers means. We also understand that sometimes web servers are not necessarily physical one-to-one, but one physical server can host many different virtual servers or containers. And then what happens now is, once that we decide how our web server is physically realized, we need to now have the software on that server, be it physical or virtual, oftentimes virtual, that runs on that server instance. And this is the web server or HTTP server as a software. Okay, so what the server as a software, this server as a software does is it makes resources available over a URL and over HTTP or HTTPS. And the standard ports are 80 and 443. And again, we've already seen that if you start your server locally, you can say localhost, or you can say 127.0.0.1, which is just a translation to localhost on your local computer to access those resources. And what the local web server does, very high level, it takes the path component of a URL, and let's remember the URL that we had in lecture 1. Here it's just localhost 3000. That's a domain or the host name and the port. And then we have the path component. The path component in this case is members/brackets. And then with query parameters. And now what a web server does is it maps this path component. So the host name and the port just decide what hardware are we targeting, right? And then a web server listens on that port that is provided here, 3000, or if none is provided, then it's 80 or 443 in case of HTTPS. And it will serve you either a static asset or it will serve you a dynamically rendered resource. Okay, that's the bare bones of what a web server is supposed to do. Oftentimes it does a bit more. Oftentimes there are more things that the web server does. And it incorporates some sort of caching, some sort of session handling, but those are things we're going to look at maybe next week. Now, static assets. Static assets means there is part of the file server on the hardware/virtual server that you have that you want to serve directly. Okay, and what the web server does is what you need to do as a developer, you say, I want to make those static assets available on this path. So let's say, for example, on the example to the right here, we have this path var public HTML. It's a very standard folder that people provide on their servers. Now we put things into this folder, right? And let's say someone accesses our server with localhost static JS search.js. So the static part in the front, that's something that is configurable. But in this case, what static does is it maps to this public HTML folder. And what we do is we translate this into the file system. Okay. What the web server does in addition is it wraps all the files that it gets from the static asset into an HTTP response. So that you can get all the headers that you can imagine. If you do a curl, for instance, on a static asset, you will still get the HTTP header. Okay. Now, the MIME type, right? So if you remember application JSON or what was it, text HTML, or what was it, text JavaScript, and so on and so forth. Now, those MIME types have nothing to do with the file system. The file system does not have MIME types. So what the web server does is it applies certain heuristics to provide the static files with a MIME type. So oftentimes what it does is it looks at the file ending and says, well, if the file ending is .jpg, this is going to be an image JPEG. If the file ending is .js, it's going to be a text JavaScript, right? And yeah, and the most common example of examples of the static files are HTML and CSS and JavaScript, right? For JavaScript for use in the browser, obviously. So everything we've done so far, even if you started a local server on our computer to serve those assets to get over the course things that we saw from modules, that was just us serving static resources. And the web server handled that for us. And then obviously media, things like images, video, audio, other documents, right? Those are also all part of the static realm. And now we come to dynamic resources. So dynamic resources are obviously more interesting. Usually, if you talk about a web server, the minimum you have to have is the ability to serve static resources. Dynamic resources is sort of an add-on. If you look at the history of the web, we started out with very local documents that we served over HTTP. And what dynamic resources means is that you are able to execute a program in a server-side programming language on the server. Right? This can be Python, this can be Perl, this can be JavaScript, any programming language that you can think of. The server will be able to execute it if you configure it that way. And now the dynamic resources within this programming language have more control of how they react to the HTTP request. So if you remember the static resources can only react to the path. They can only say, take this path, map it to a local path on my web server, and return that. That's all they can do. But in the programming language, you can do a lot more. You can, first of all, you can also react to the path. You can say, here's a path, do something with it. And then you can also react to query parameters. Let's say you provide some parameter to the programming language. It can read the parameter and react differently depending on what the value is. It can react differently based on the method. So you can, in the HTTP request, you can see, oh, this is get, or post, or a put, and can react differently. It can react to other headers. Let's say you have a header accept application JSON, and that's part of the content negotiation. So let's say, while the path, for instance, and the query parameters are the same, if a header in the HTTP request is different and asks you for a JSON, you might provide a different representation. Okay. So at the very bare bones minimal, what that means is that the programming language takes all these things from the HTTP request and then constructs a response. And in the very early days of web servers, that was you just printing out things. And I'm going to show you in a couple minutes an example of how this looked like. So, and that's an example of Apache and CGI. But oftentimes, yeah, the system output was treated as the complete response, even with the headers. However, nowadays, and I just want to show you the bare bones part so you know what the underlying concepts are. But nowadays we have frameworks and we have libraries to help us construct the HTTP response. They help us deal with things like cookies. They help us deal with things like post bodies and form submits and all that stuff. And how exactly that works with an example of Node.js and the framework called Express is a topic next week. However, this week I want to show you how that works on a really super low level. So that's actually the last slide I have for today, but I want to show you examples of web servers. Concretely, I want to show you the Apache HTTPD example with CGI. So CGI stands for Common Gateway Interface, and that was the first a way of providing dynamic aspects from a web server to the client. And there's a GitHub repository that I'm linking here that has all the code in there, so there's no need to take screenshots or anything. And I want to mention Nginx because Nginx has gained a lot of popularity in the last, I would say 10 to 12 years. And with Nginx is not only a web server, it's also a reverse proxy. So while you can use Nginx for everything that you need within a web server, because it provides two components, you can also say I want to have Nginx as the front end of my requests, and then I'm gonna relay my requests to an underlying process or other web server. So you can also combine Nginx and Apache actually. However, I feel like that's not necessarily a topic that I want to go into detail right now. I think it's interesting in itself, but it's not something that you will need to kind of master the basics of web servers or web engineering in general. What we'll use in assignment 3 is we're going to build our own standalone web server through Node.js. Node.js is basically JavaScript on the server, so not JavaScript within the browser. And in there, we have some libraries. In this case, the library is called HTTP. That gives us a very basic capability of writing our own web server that starts up when we start up the process of Node.js. And this is a very basic example of that I will show you in just a minute. Okay, so that's it from the lecture part. I want to quickly show also a demo. Are there any questions on the lecture part? Let me see that. Any hands up? Oh, there's one hand up. Mark, let me unmute you. Yes, Mark.
Hello, can you hear me?
Yes, I can hear you.
Okay. Hi. I would like to ask. You mentioned the virtual servers.
Mm-hmm.
I would like to know if they are actually sharing the same IP. like on the physical server, like if you have several virtual servers running on a physical machine, if they're actually sharing the same IP address.
Right. Yes, fantastic question. So virtual servers can share the same IP address. So you can have man, what was it called? Natural address translation, I think. It's been a while since I've done networking, but they can share the same IP address, but they have their own device, so to speak. It's a logical device of Ethernet, and they can request their own IP from the DHCP, for instance, or they can provide their own IP. And oftentimes, if they are on a server, they usually have their own IP.
Okay. Another question that I have is, I'm taking another course at the moment. It's called Software Engineering and Project Management. Mm-hmm. And there we're working a lot with Java Spring and REST APIs and stuff like that. Mm-hmm. And I'm not trying to make up in my head, like, so to say, when should I use, like, for example, JavaScript and Node.js for a web application, and when to use REST API and Java Spring, or what's the difference, or when to use what?
Right. Okay. So there are a few things that are related here. So REST has nothing to do. Oh, wait. Let me just microphone back here. So REST has nothing to do with the underlying programming language. REST is just representational state transfer. It's sort of just a way of how you design the endpoints that you then map to the logic in your programming language. Okay, so that's one thing. And then whatever you use as a programming language doesn't matter too much. In this course, we're going for Node.js and in this case JavaScript, just because I didn't want you to learn a different language. We could have easily also gone for Python. We could have gone for Java and Spring. It doesn't make much of a difference actually. In this case, we went for Node.js because it's very popular. It is well documented, I would say. There are a lot of resources out there, and it's the same language you're already using for for the other assignments. That's the only reason, right? In the end, it's sort of a preference that you have for going with the technology that I would say goes beyond the simple conversation. But if you want to, I can talk more about that maybe next time.
Okay. Thanks. Thank you very much.
Sure. Okay, Alex, now I see your full question. Yes, the lecture is going to be recorded, and the recording will be on YouTube on the playlist that I already have for the other lectures, and I will also link it into them. Okay, any other questions? None so far. Let me see. Okay, so with that, I want to show you one more quick thing. So yeah, if we go back here, let's just copy this link from here. So on the web engineering GitHub, you can see this Docker CGI Python. Docker is one of these container technologies that you've probably already heard of. And what it does is it gives us the ability to kind of spin up an isolated process that looks like a server locally. And what this will do is it will start a web server, an Apache web server, and it will have this CGI thing, the common gateway interface that I talked about earlier. Okay, and let's have a look at that. Yes, nope, there it is. So let's go into the Docker. So what the Docker file is, it just describes the steps you need to make on a server to arrive at a certain infrastructure state. So what we do here is we start from Ubuntu. So that's an image that we get. We install Apache 2. We install Python 3.8, and then we copy over some configuration here. Well, actually, this is all just environment variables. Right, then we copy over some scripts that we prepared. And then we also copy this configuration here. And then in the end, we expose it at port 80. And if we go, and I wrote some convenience scripts. So if you look at this, if you want to try this at home, you should start with build, which builds the Docker image from, built the Docker image from the Docker file and the resources we have here. Then you can say run, which runs the container in the background as a daemon. And there are other things like attach. If you want to kind of jump into the server and attach a terminal to it, which I've done here actually, we can do that also, right? And so with that, I want to quickly show you what happens. So as I started the server, and yeah, if you look at Docker PS, you can see that I started running the server 4 hours ago. And the command that it's running is Apache 2. And what I did, if you look at the run, I mapped port 80 from the container to port 8883 on my local machine. So what I can do here now is I can say, well, locally, I say localhost 883, right? And that will give me, in this case, will map the static resources that I have here. And the way it does that is there's some configuration going on. If you look at the Docker file again, there's some configuration that says, well, the var .HTML folder is my static folder. Everything that is in here is static and will be served as is. So if we go, and this by the way is just me running within the container. I just attached the bash process, and now I'm in the container. This is not my computer anymore. That's the Apache 2 container. So here I can go to var and HTML exactly. And here I have 2 files. Let's do one more file, web engineering, right? or actually let's call it .json and say, well, the messages are hi. I don't know, some entries. Okay, and now if I go here and I say .json, then it serves me this file as is. Okay. If we go, let's see if it's a well configured, because this might actually be, I think it returns HTML all the time, which is a badly configured web server. So let's say curl. Let's see what it does. Oh, okay. So it does return content type application JSON, right? And it does so based on the ending that I give it. There's nothing else. Now, there's another folder that is interesting, and the folder is in /production /www and then CGI bin. Now, in this folder, I have these files here, which are Python and something called CGI. The reason why this is allowed to be called CGI is because it's configured that way. So somewhere in Apache configurations, they said that this is allowed to be an ending. And if you look, and actually I opened this in Sublime somewhere, yes. So if we look at this, in CGI, what you needed to do is you needed to tell Apache in this case, or the CGI mod in Apache, what kind of process you want to run. What kind of program is this? So in this comment here, basically you say to run all of this, go to user bin Python 3.8 and run this. Okay. So, and you can see here is what I print here is already the response header. So in order for all this to work within this bare minimum CGI, oh, okay, I see a question here. What is Docker in general? Oh, okay. So Docker is one of these container technologies that I mentioned before. So while containers in itself are something separate from Docker, Docker is just one instance of software that deals with containers. I feel like Docker has become the contemporary, let's say, favorite when it comes to dealing with containers, because it makes the user experience much easier. If you have dealt with containers, let's say 10 years ago, before Docker existed, or even 8 years ago, it was kind of a pain. And with Docker, it is a lot more seamless. Florian has, so Florian asked the question, if I permanently run an Apache server on my machine and open the port on my router to access it from anywhere, how safe is this in terms of hacking my machine? That's a good point. So if your firewall allows access from outside, in most cases, your local home router has a built-in firewall, and you open the port for this, what can happen is there's certain software that can scan IP ranges, and many people do, right? They scan a bunch of IP ranges, and within these IP ranges, they also scan certain ports. So certain ports are more vulnerable than others, and based on that, they can have access to the information that you offer on that port, or resources, or ability to change things on your computer. So just be aware that if you open the port on your firewall and outside people have access to it, people may be able to scan IP and port ranges. Hope that answers your question, Phil. So yeah, be aware of the security and all that. So yeah, so maybe just another point here. I haven't mentioned security at all, or performance of web servers. I think they're both super interesting topics. I just think it's going to be a lot to handle for you anyway in this course. So I left security and maybe performance for other courses to look at. especially security. There are a lot of interesting courses at TU Wien. There's internet security, there's introduction to security, there's advanced internet security that deal with all these things. Basically, what I can say for security in terms of web servers is certain standard configurations can be vulnerable. So always check that you don't have the standard configuration on a production server. If possible, on production servers, always enable SSL or TLS, so have a secure connection, because every time you transfer data or HTTP, it is plain text, basically. Everyone who is in a certain network can sniff those packets and can see what you're sending if you don't have it encrypted. And otherwise, if you're writing a server, as we will do in A3, don't trust any input. Any input that comes in can be potentially a security issue. So every time an input comes in, sanitize it. And with that, I want to move on and show you how terribly insecure my other scripts will be, but that in a second. So if I go now to this here, so this is a CGI thing I said before, right? And it doesn't do much. It just prints those things. If you look at the script, that's all it does, right? And it imports this library that we have provided a folder for. Not that interesting. But what is interesting, I think, is that you have to provide those response headers. If you don't do that, then it's not going to go well. And interestingly, you can do this for shell. So this is a shell script. This is something that, is not, some people might say it's not a full programming language, but, it can do a lot of things. It's Turing complete. And you can certainly write your backend server simply with shell scripts. I wouldn't recommend it, but you could. Now let's go through a few examples that are, oh no, did I do? How can I go back? I probably can't. Oh, there you go. Okay. I wrote a few examples for a very simple script in CGI, and this is Python, so I hope you can follow along here. It's a very simple syntax. So I copied this function that provides me prime numbers up until a certain range, right? And then what I'll do here is I'll say, well, give me all the prime numbers until 100. So here I have a loop and I print something. So I go back here, I do that. Right, so that's all nice and good. But now, why is this 100 fixed? So I want to have this 100 sort of variable. So what I wrote is another script called, no, not this one. Actually, I want to have the other one. .py, yes. I have the script called prime until .py. And what that does is it takes this parameter. So I can say 400, for instance, and it will give me all prime numbers until 400. So if I go back to my script here, this one here, the difference here is that Python now has a library that helps me with doing this. So this is the first help we're already getting from the programming language in terms of library. So I have this CGI library that I import here, and I can say cgi.fieldStorage. And what this provides me with is a method of getting the query parameters. Say params dot get value, and I get this until value. Notice, by the way, that I'm not checking what comes in here. This is not good, right? Well, I'm doing the int here, which kind of offsets some damage, but usually you have to sanitize and check your inputs, especially if you're just using strings as is. And yeah, and always, if I just don't provide a value, it will probably crash. Yeah, there you go. So that shouldn't happen if you program properly. But in this case, this is for demonstration purposes. Okay. And if you look here, it's the same as I did before. I just introduced this parameter. Now we have one last example, which is what you saw before. It's called the prime until all, right? If I do the same here, it's the same thing. However, I have this other parameter here. It's called, and I think it's what's called type. Right. So what I do here is I organize the code a bit better. And what I say is, well, if you provide me with this parameter type and the type is JSON, print JSON. Or if I say type equals JSON, right? It will now return the prime numbers as JSON to me. right? And the way I do that is, or what I want to show you here is that based on everything you can get from an HTTP request header, you can use to guide the behavior of your server or your backend in that sense. So in this case, I print JSON, and also pretty much the same thing as I do here. I just say content type is application JSON, and then I print a different representation. And the last thing I want to show you, let's actually tear this down. We don't need this anymore. Now say clean. My computer is doing overtime. There you go. Okay. Yes, exactly. So remember the last kind of snippet that I showed you? It was this server here. Okay. And this is the bare minimum server you can use for starting an HTTP server only with Node.js. So Node.js is JavaScript on the backend, and this is the simplest thing you can do to start a server there. Right? You can say npm server.js. Okay, and this what happens? Whoops. Sorry, not npm. Node server.js. That was a typo in my case. Sorry about that. Okay, and if you go back to the server, this does nothing, right? It just starts to listen on port 8080. So if I go to port localhost 8080, and it will just say hello world. If I change this, okay, what will happen now? It's still hello world because we have to restart the server. All right, so here we have to kill this, start it again. Okay, and we have this new thing. So next time we're gonna pick up exactly here, and we're gonna talk about all the different abstractions that we want to have to make this easier for us. Because right now, if you continue on this path of just using the bare minimum of things, it will be very difficult or very tedious to build application behavior based on that. So next time I'm going to go through the concepts that are interesting on the web server and HTTP path that we can use to design maintainable and performant web applications. And those are things like dealing with request headers, dealing with parameters, dealing with the HTTP method, dealing with cookies and sessions, and so on and so forth. So with that, I want to close this lecture, and there are a few questions left. If I disable, so there's another question by Florian, if I disable port forwarding, can there be any threat? So if you disable port forwarding, and if the firewall does not allow you to access any of your local computers over that port, that shouldn't be an issue. There's another question by another Florian, do we also get those? Yes, all those examples are in this repository. So if you go here and you go into CGI bin, you see all of those, and if you run the Docker container, you can see them in action also. Okay. Are there any other questions? Florian Lackner, do you want to ask another question, or? If yes, I've unmuted you. Okay, it seems like there are no more questions. So with that, I want to close this week and look forward to start doing some programming in Node.js and Express, which is a framework, next week. Thank you.